Hi everyone, welcome back to our channel. Today we are going to solve this problem number 31. So what is given in the problem is for the network shown below when V naught equal to 0. So the problem given is, so he is saying that the same network is given and the value of V naught equal to 0. So which says that this source is deactivated, and he is already specifying the current in this branch is IL dash is equal to 2 amperes. Okay, so this is the network and this source is in active mode. Okay, so when I naught is active and V naught is deactivated, this is activated and this is deactivated, and the current is already given in the problem, so half of the solution is given in the problem. So what we need to find out is when the second source is excited, find the current in the resistor. Okay, so when this source is excited, okay, we need to find out the current. So whenever this source is excited, this I naught will be deactivated, so I'm going to draw it. So now this is deactivated and we are having a 2 ohm, and this is another branch, and this is the branch, and we are activating it, and the voltage of this given in the problem is 10 volts is flowing. This is 2 ohms and this is 2 ohm. So the current in this branch is nothing but IL double dash. See here, for this voltage source is excited, actually the current starts flowing to here and it will come to this junction, so it doesn't divide. The current in this branch is how much? 0. So therefore the current doesn't flow in this branch. The same current will flow here. You can see here it tries to form an closed path. I can say here these two elements are now connected in series. Therefore with an excited voltage of 10 volts, and these two will be connected in series. Therefore 2 plus 2 is how much? 4 ohm, and this will be the current IL double dash. So IL double dash is equal to, what is the voltage at this point? 10 volts. What is the voltage at this point? 0 volts. So 10 volts minus 0 volts. The current is flowing like this. Okay. 10 volts minus 0 volts divided by R, which is nothing but 4. 10 divided by 4, which is nothing but 2.5 amperes flowing from top to bottom. So here also this is flowing from top to bottom. Therefore the total load current IL is equal to IL dash, and next one is IL double dash. So this is also flowing from top to bottom. This is also flowing from top to bottom. Flowing from top to bottom is indirectly, this is flowing in counter clockwise direction. This is also flowing in counter clockwise direction. So automatically both are in of the same counter clockwise direction, then you're going to get it as sum. So what is the initial current IL dash given in the problem is 2 ampere, and what we have been calculated is 2.5 ampere, which is equal to 4.5 ampere. So this is the total current IL flowing in the circuit. Hope you had understood the problem. So this is how to find the solution by using a principle. This way of addition is called as a superposition. So that's why this theorem is called as superposition theorem. So you can see the procedure. This source is activated, this source is deactivated. Later this source is activated, this is deactivated, and we find the currents. This process is called superpositioning method. First, this theorem is called superposition theorem. So hope we find the solution for the given problem IL dash. So if you feel my explanation is good in solving the problem, please like the video and share the video to your friends, those who are watching the same subject. And if you have any doubts, let me know in the comment section. And if you're watching the channel for the first time, subscribe to my channel with the name KV Tulsiram. So thank you for watching. Kindly support this type of free channels for the betterment of students as well as for the faculty. We'll meet in the next video. yours wrong.